Hello everyone. So today we will learn double integral in polar coordinate. Okay, double integral in polar coordinate. Also we will see how we can integrate, how we can evaluate this integral using double integral. Okay, so before going to the double integral in polar coordinate, let's see. Suppose we have a region, suppose we have this region, this is a xy plane. Okay, this is xy plane and this is a disk of radius, suppose this is distance a. Okay, so how this region can be described? Suppose this is my region D. Okay, this region is D. How I can describe D? D I can write it as x comma y such that x square plus y square is less than equal to a square, right? Now can we write the same region in polar coordinates? Yes, of course we can write, but how it is look like? Suppose in r theta, if you want to see this one, suppose this is my r, this theta, r theta plane, because polar coordinate every point can be represented by in r comma theta. So r comma theta it is represented by how it will look like. So this d star, that means you see this theta will be varying from this is 0, this is this whole 2 pi, right? So theta is varying and this r is varying from 0 to 1. So this d star will be, means equivalent polar representation is r comma theta such that r is varying from 0 to a and theta is varying from 0 to 2 pi, right? So how it is look like in r theta plane? So r theta plane, it is look like here it is r is varying from 0 to a and theta is varying from 0 to 2 pi. Okay, so now you can see that this is my d star. Now how it is in xy plane, it is look like a disk. Okay, but same equivalently it is look like a rectangle in r theta plane. Okay, now what our double integral in polar coordinate means, we can see that this integral, if you are integrating over this d of any function, okay, f dx, okay, x comma y dx dy, okay, this is equivalent to integration over d star f r cos theta r sin theta and this is r dr d theta. Of course this r comes from the Jacobian. Okay, this quantity, this is the absolute value of d of xy of dou of r theta. This is Jacobian. Okay, absolute value of Jacobian. Okay, so this is the formula for evaluate double integral. Okay, in polar coordinate. Now we'll see how we will solve this problem. What is the value of this one? Okay, so before that let's evaluate this integral. Evaluate this integral. What is this? E to power minus x square plus y square, and we have to evaluate this integral in the region of this one, means this region. This is a disk of a radius a. Okay, in this region, okay, I am writing this region as d. So this integral is over d. Okay, so how we will integrate? So we will convert this into polar coordinate. So we will make the transformation x equal to r cos theta, y equal to r sin theta. Now if this is the case, then what is e to power minus x square plus y square? This will be, okay, now from here you can see that x square plus y square equal to r square. Okay, so this will be e to power minus r square. Now what is this is, look, this is d, that means what is our d star? Our d star will be this one, right? This is r theta plane, this is a, this is 2 pi. In r theta plane, d star is this one, right? So what if you integrate over d e to power minus x square plus y square dx dy, what you will get? According to this formula, this will be the integration over d star, and we have to replace this by r cos theta and r sin theta. Okay, after replacing, anyhow we are getting this one, and r dr d theta. Okay, so this will be integration over d star e to power minus r square r dr d theta. Okay, now our integration becomes simpler. So now if d star the region is r is varying from 0 to a, e to power minus r square r dr d theta, and theta is varying from 0 to 2 pi. Okay, so if you will integrate first with r, what you will get? This 0 to 2 pi minus 1 by 2 e to power minus r square, and it is evaluating from where? A and 0, evaluated at a and 0. Then this will be again integrated with theta, right? So okay, if you will put a and b, so finally we will get 1 minus 1 by 2 common, 0 to 2 pi, and okay, this will be minus e to power minus a square minus 1 d theta. Again we will integrate with respect to theta, you will get so 0 pi. Okay, finally you will calculate this one, so this will get 1 minus e to power minus a square. Okay, so finally we are getting this integration over d e to power minus x square plus y square dx dy equal to this one. Of course this d also can be written as like this, x square plus y square is less than equal to a. Okay, this is the integral. Now let's see, we are integrating this one over this disk. Now see this disk, this is the disk. Okay, this is a, this length is. Now suppose a will tending to, okay, a is tending to infinity. If a is tending to infinity, this d become, okay, it will vary, here also it will vary. So this will be whole of R2, this region. Then our d will be whole of R2. That means this region will be, okay. Also, as if you are putting here, if a is limit a tends to infinity, as a tending to infinity, what is the value of this limit? 1 minus e to power minus a square. What is the value of this limit? As this will be go to 0, so this limit will be pi. Okay, that means, so as a tends to, so d will be r square. Okay, so this is r2, and this e to power x square plus y square minus x square plus y square dx dy, this will be equal to pi. Okay, because I am applying both side limit a tends to infinity. Okay, so this will become r2 and right side become pi. Now we see, if it is r2, we can represent how you can represent r2 means like we'll represent in minus a to a. Suppose here it is minus a to a. We'll represent, like we can represent this like a improper integral, because what we have seen, this is a improper integral. Okay, this is a improper integral. So how we'll evaluate that? We will just apply by this limit form. So I can write like this also. This implies this limit a tending to infinity, this integral over, okay, minus a to a to minus a to a, right, e to power minus x square plus y square, this is dx dy equal to pi. Now if you will first we will evaluate this one, so it will limit a tending to infinity. Now you see, I can write this as I can write this as e to power minus x square into e to power minus y square. So see, since I am evaluating with respect to x, e to power minus y square will be constant, so it will be come out. So I can write like this: e to power a, e to power minus y square constant came out, and this integral will be this one, minus a to a e to power minus x square dx, and whole integral with dy. This is equal to pi. Now you see that this is a function of x, and we are integrating with respect to y. That means this is a constant. For for y there is no contribution of y, so I can take this out. So limit a tending to infinity, integration of minus a to a e to power minus x square dx, okay, into this integration minus a to a e to power minus y square dy, and this is equal to pi. Now you see that this is of course a dummy variable, so you can choose any variable. So same, I can write limit a tends to infinity minus a to a e to power minus x square dx whole square. Okay, now x square, this is a whole square, so x y equal to x square is a continuous function, so I can put limit inside it. So this limit a tending to infinity minus a to a e to power minus x square dx whole square means limit I can put inside. Why? This is because y equal to x square is a continuous function. If it is continuous function, then we can just take inside limit inside a function. Okay, so this limit will be minus x square dx, this limit will be pi. Okay, so this limit will be root pi. So if I'll apply the limit, what will get left hand side? Finally we are getting this left hand side, minus infinity to infinity e to power minus x square dx. This is equal to root over of pi. Okay, so this is the final answer. Hope you like this video. So please review it, and if you are anything you are unable to understand, please write down in comment. Thank you for watching.